you should see my PowerPoint presentation. Okay, well, so thank you everybody for being here. Today we will talk about .NET 5, 6, and 7. It will be a rush. I cannot use another word for this kind of session because we will tackle a lot of topics and a lot of different stuff that has been released in .NET 5, 6, and 7, of course, as well as .NET Core 3.1. It's the old age of .NET. Yeah, and we will focus mainly on some new stuff in .NET, but also on some new data types, some new syntax, and whatever. We'll do it. It will be a rush, and I hope you'll get some nice gems you can use in your new code base. Before moving on, just a few words about me. I'm Davide Bellone. I live in northern Italy, in Turin, and I'm a software developer with around 9 years of experience in the .NET, in the Microsoft world. So I began as a SharePoint developer and then a full backend developer, etc. But C# was my companion since the very beginning. I share content on Twitter and on LinkedIn in small bits, and my main content is published on my personal blog, which is codeforit.dev. Of course, I will talk about C#, .NET, Azure, and whatever. And also, I'm a Microsoft MVP clearly for C# and .NET. It was pretty easy just to summarize myself. So let's start from the very beginning. Where are we now? Of course, we had the dark age of .NET Framework, and then they released, of course, .NET Core with the very first versions that were pretty terrible. But then finally, in 2019, they released .NET Core 3.1 and decided that every year, they would have released a new version of .NET. As you see, the versions are divided into main streams, the LTS and STS. LTS is the long-term support. So every release is supported for 3 years. So with, of course, the security patches and whatever updates. And STS is the other stream with very short releases. So it's about 1 year. Right now, we are, of course, in .NET 7, released in late November 2022, which is, again, a short-term standard time support version. And they will release a new LTS version in late this year, so in November. We have some previews on what will be released in the new version. But in this topic, in this session, we will mainly focus on what has been released with .NET 5, 6, and 7, just to know and to update your current code base if necessary. Clearly, with every version of .NET, they also release a new version of C#. They go pretty independent, but they are similar path. So, for example, with the release of .NET 5 in 2020, they released C# 9, again, .NET 6 with C# 10, .NET 7, and guess what, with C# 11. And of course, we will also have a new version of C# with some new bits and some new details. Okay, but we don't have official data about the usage of the newer versions of .NET. So my only guess was to create a poll on LinkedIn and on Twitter. And apparently, most of the developers are already using .NET 6 and .NET 7 for the production ready projects, but some of them are still working on .NET Framework and on previous versions of .NET. I suppose that people working with .NET Framework are are bounded to that specific version because of external dependencies, or maybe they are working on legacy projects or whatever. But by the way, the majority of the users that reply to this poll are using the newer versions of .NET. In particular, they're using the stable version, so .NET 6. But still, a lot of people are moving to .NET 7, and I suppose they will pretty quickly move to .NET 8, of course, later this year. Again, we don't have official data about the usage, but we have some official data about the performance of .NET 7. They released a kind of benchmark of a comparison of API performance with ASP.NET Core and Node.js, and you can see from this image that .NET is actually able to handle a lot more requests per second compared to Node.js. They created an extremely I don't know. But by the way, they created an environment that is able to handle a lot of requests per second. It's extremely optimized, and of course, it's a good choice if you are building a solution that needs to handle a lot of users per second and concurrently, of course. This is the general idea of .NET 7. Of course, there is a lot more, but now we can finally move to the code with some of the stuff they released in the later versions. Let me, okay, and slideshow, okay. And finally, let's go back to Visual Studio. The very first topic I will share is it's called top-level statements. It's a brand new way to handle console applications without all the burden of the public static void main structure and the namespace and whatever. You can just drop here or your code and execute it pretty easily. This has been released probably to developers coming from other platforms to approach .NET without all the fuzz of the structure and namespace and whatever. Pretty easy. Probably some of you already have used it. I don't know. It's a nice thing, but of course, nothing compared as the async main new way to handle console applications. If you recall, for legacy and for older versions, we had the synchronous version of the main method. So we also had to rely on the dot result or dot get away and get result stuff and whatever. Of course, working asynchronously in a synchronous environment is not the best for the performance and for your projects. So they released a main which is natively async, and it's a pretty good stuff. Nothing fancy again. Let's move to another pretty nice gem, which is the global usings. I find this part particularly useful because in many projects I also have to include every time the same libraries and same usings. So I don't know, system.linq and unit.framework and whatever. And of course, you come up with, I don't know, 15 usings per file. It doesn't make sense. So they created a global using file called, guess what, usings, with the global keyword, and all those namespaces will be applied to every file within the same project. It's a pretty good addition to .NET. And I use it pretty much in every project, so it can be useful even for you. But clearly, the main the king of the new releases is the minimal APIs. So if you need some quick to create some quick API applications, but you don't want to create all the controller, implement the class, and create everything, etc., you can just put all your endpoints within the program.cs file. So it's the class. Define all the routes and all the HTTP methods to be mapped. Handle whatever you need. In this case, I use the plain old weather forecast example to return, of course, the forecast. And you can also apply Swagger or OpenAPI to those endpoints. This pretty much simplifies the creation of web APIs if you don't need all the burden of the controllers. So it's nice, but honestly, I prefer working with controllers because I prefer to split all those different endpoints in different files. So it's just personal opinion. Those were the main topics about .NET, but now we can focus on what has been released in C# with the latest versions. We cannot avoid talking about records. We also had classes and structs. Each of them has a reason to be. Now we also have records, which is a different way to define data structures. Instead of creating, public class user, and then the braces, and then the constructor with the public properties and whatever, we can simplify the syntax using public record using user and specifying the name and the type of the properties that will be automatically created for you. So it's just a matter of one line, you create a whole class with the public properties. Clearly, in fact, we can create a new user and access the public properties for automatically mapped for us. It's nice because we also have automatic quality checks. So if we create two different instances of a user with the same properties, they are marked as equal. So we have automatic checks, but of course the two instances, so me and also me, are equal because their properties are equal, but they're not the same. So those are two different instances, but they are considered as equal. Nicely, they also implement an automatic toString method. So instead of using if you recall from classes, when you create an object and then call the toString, you get the name of the class within a space and all that stuff that has never meant anything for us. Right now, if we need to call toString on a record, I don't know, maybe for debugging, we have the type and the description of the public properties. So it's nice to know this. This thing is pretty useful, especially for debugging. Of course, for production code, I would not print this kind of string clearly. One of the most important things about records is that they are immutable. Once you create an instance, you cannot modify it. So, of course, here I created a new instance of user. But when I try to update the name, I get a compilation error because, of course, those properties are read-only. Once you create them, you cannot update them anymore. But of course, if you need to update it, maybe by changing just one property, you can do it by cloning. So you can create a new instance of the user, and by using the with keyword along with the braces and the name of the properties to be updated, you can get another instance of user. you don't update the previous one, of course. You create a clone with the new, in this case, new name, which is Mr. Davide. Again, here the comparison, in the test, you can see that the other properties are still present and coming from the source. So of course, another.id is equal to 1 because 1 was the ID of the previous, the source, let's call it user. But now let's go a step further. We can also have inheritance when working with records. So I can create a developer that is a subclass of user. Again, you have to define all the properties in these in the brackets, but you can also add some new properties that are specific for that specific data type. So developer will also have a list of skills. So clearly, when I create a new developer, I can check that developer is, yes, of course, an instance of developer, but also of user. So we have inheritance in records, and it's pretty much much useful, especially for videos and dynamic mappings, whatever. One of the first things I told about records is that they are immutable. Yes, but actually no. They are immutable for the, let's call it the first level, so for the reference, but they're not frozen as an item. So again, if I create a new developer by specifying a list of strings, I cannot change the reference to the ID, the name, and the list, but I can change the content of the list itself. So it's immutable, yes, but just the references. You can update everything that comes below that first level, let's call it. So I can actually add a new skill, and the count will be 3, the first 2 plus the one I added before. We saw that we can define all the properties in the brackets, but we can also expand records with other properties. So in the old way, so public string and with get set whatever, and we can actually add additional fields in that way. So using explicit properties. So I can create again a class, an instance of C# developer using the constructor, and then specifying the other properties that are not part of the required fields. We saw that there are similarities between classes and records. Another one is that a record can be abstract. You can create an abstract record named person and create some classes that implement that specific record. So, of course, I have a teacher and a student that are subclasses of person, but I cannot create a new kind of person because, of course, it's abstract. And this again, it's a pretty nice gem about records. Finally, and then we will close the records chapter. A record can be abstract, so they act as classes. But if you prefer, if you need to handle them as structs, you can. You just mark them as a record struct, and they work the same as we saw before. And records is one of the most important updates in C#. I forgot to say that if you look at the examples, they are marked with an attribute, a custom attribute I created for these demos, and they tell you which version contains this new specific functionality. So in this case, with .NET 5, they released abstract records. It's just for you if you want to try them in your code. Let's move to other types that have been released in those versions. So in .NET 6, they finally released the 2 data types, time only and date only. Previously, we had datetime and datetime offset, but they required you to specify both the date and the time of a specific event, of a specific instance. Clearly, sometimes you just don't care about the date or the time. If you want to set an alarm every day, you don't want to set this specific date. It's every time, every day at 7 a.m. Okay, so now we have time only. Similarly for the dates. So my birthday, why should I have to specify the time of my birthday? I just don't care. I need the date, and it's date only. Clearly, you have with date only year, month, day, whatever you need. Similarly for time only, hour, minute, seconds, and so on. The two strings, whatever. Those are nice stuff they released in .NET 6 finally. And one of the most required data types in .NET is the priority queue. We only had the basic queues, you know, the first in, first out class, etc. But now we have the priority queue, where each item is defined by a type, so the type of the item itself, and the type of the priority. In this case, I create a priority queue that holds a list of a collection of tasks to do. Guess what? Marked as record, and whose priority is marked as integer. Clearly, one is the item with higher priority, and of course is the reverse, as you might think. So you just create it and queue the items by specifying the priority. And when you pick the item or take the first item up from the queue, you get the ones with the higher priority. So in this case, when I pick the item on top, it's wake up, because wake up is the one is the item with priority equal to 1, which is higher. And again, of course, you can add the new item with MQ, DQ items, etc., etc. This is a pretty useful, and finally, it's native in .NET. Those were the three main data types I wanted to talk about. Now we can move to the syntax. Yeah, let's call it syntax. Even if it's actually a keyword, the init keyword. That was a keyword I honestly didn't understand why it existed. I mean, we have get and set, we have the constructor. Why not? Well, it's not enough. Actually, it makes sense because using the init, you can create an instance of, in this case, person, but you cannot update the value once they have initialized. That's similar as records. So of course you can create them and define them at the first time, but again, you will get a compilation error when you try to update an item that has already been set. So init is a pretty addition to the syntax, but you can use it only if necessary. Of course, if you need to set an item, of course, use that. I don't know why they don't set it as the default. It would make sense in my opinion, but let's see the future what will bring. And now we can move to dictionaries. Here it will be only about syntax. They didn't add new stuff, except in fact a new way to define items in a dictionary. So the very first version, so you had to explicitly tell dictionary.add 1, 2, 3, etc. Finally, they moved to this new version where you create an instance of the dictionary and then specify within the square brackets the key and the value, but after you have created the dictionary. Now you can do it, let's say, inline. So you call a new dictionary, and within braces, you add the initial values that will be stored. Again, nothing fancy, but it pretty much simplifies the readability of your code. So if you compare this part with this one, it's a different ballpark. Clearly, you can again do a step further. Instead of declaring the type on the left side and on the right side of the instruction, you can use the new keyword. So you define the type of the instance of the variable, and then use just the new keyword instead of repeating the name. So instead of doing user equal new user, you just call new, and that's it. It creates a default instance of user. Of course, the same for dictionary. So you can create more complex objects. Let's stick with syntax and move to pattern matching. That is a quite different topic because I don't like the syntax, but it can be honestly useful. So I want you to know that at least it exists. Well, first of all, you can see that I created a function, a method that lives within the specific method. So it's a thing that you can do. It narrows down the scope of the specific method. So of course, once you create it within the can use keywords, you cannot call isLetter or separator outside that method. It's not bad. But let's stick with pattern matching. As you can see, here I specify this expression that uses some new keywords. So for example, you can say that C is greater or equal to A, and so using the explicit word, less or equal than Z, or. So you can use this new way of defining an expression, considering that the object is defined at the beginning. So you just say that C is, and then the list of expressions, instead of saying C equal than greater or equal than A, or C is equal than Z, or whatever. You can simplify the syntax in this way, and it's much more readable. Clearly, you can also use this new way of checking for nulls. So you say that S is not explicitly null. So instead of exclamation point equal, S is not null. It works also for complex types. So for example, an array. Here, the self or message method accepts an array of integers and returns ciao only if the input is exactly equal to the array I defined here. So if it's exactly equal, it returns ciao. But if you add a new item, or it just differs for the position, it's considered as a different array, and it returns, in this case, error. Of course, sometimes you don't care about all those specific values. You just care that in the second position, you have the number 2. So you can use the discard value. So in this case, clearly, I return ciao if the second element, so position number 1, is exactly equal to 2. So just the first one. The other ones do not match because, exactly because the second item is not 2. And also the number of elements is different. In this case, I am expecting an array with exactly 3 values, but here we have 4. And then we can do, again, a step further. So storing in a variable, in this case, the third element of the array. So, okay, we have checked that the first in the first element, we don't care. The second element is exactly 2. And now we want to get the third element of the specific array, so that we can use it for further elaborations. We can do it by defining int, in this case, int third, and the third element will be applied to this variable. It's just like the out pattern that we see in try parse and whatever datetime.try parse. It's pretty useful, and of course we can mix all those parts by specifying that the first element must be 0 or 1. The second element must be greater than 2, and then we can store the third element. As you can see, the first example returns chow_3 because the first element is 0 or 1, the second element is greater than 2, and the third element is 3. All the other instances will not match because one of those filters do not match. This can be useful, for example, for validation or logging or whatever. It can be useful. Of course, here the example with the numbers does not make sense, but I need an easy to understand example. But you can use it for data validation, for example. Let's stay a bit with the pattern matching, but this time we can move to the switch statement. So we can add a switch over an instance and check for this type. So for example, here I have media, and media is defined here, okay? Media is a class that has just one subclass, which is video. Nothing fancy. As you understand, those examples are pretty basic, just to showcase the syntax and the different stuff. So again, we have a switch method. We can add a filter on the type, the runtime type of the instance, and then store that value already casted to, in this case, video, to a local variable, and reuse it in our switch block, in our case block here. Clearly, we can join pattern matching with switch statements by saying that the input media must be, for example, a video, and the specific duration must be greater than 5, and then do something. Otherwise, move to the other branches. This can be useful, for example, for error handling when, I don't know, you have an HTTP message, HTTP request exception, and you want to check the status code or something like this. You can use this syntax to handle stuff properly, but we will see that later. They also simplified the general structure, the general syntax of the switch block. So you can actually apply a switch statement directly to an instance of an object, to a variable. So by using directly name of the variable, media, switch, and then apply all the branches. So in case media is a video, return this string. Otherwise, so discard, return a default text. Clearly, we are using the arrow syntax, but I suppose all of you already know it. Finally, we can, of course, apply some more filters on this new syntax by using braces. So when a media is a video and this video is public, then return something. Otherwise, move to other stuff. And that's pretty it. Again, this can be pretty useful, especially this new syntax, when you want to create methods that are just inline because you want to map an input to another different type. With just a switch block, you don't have to create all the method with the whole switch block with the cases, etc., etc. You can just apply it almost in line, and it pretty simplifies everything. Then, as I said before, we can handle exceptions and data types. Okay, you can use actually the switch pattern, switch blocks and whatever, but there's a better way. So by applying the when keyword to a catch block. So what happens? When I call this method, I execute the try part. Okay, an exception is thrown. I can, of course, filter by exception type, but this is native in .NET since the very beginning. But now I can also add a new check on the actual instance of the exception. So in this case, if the exception thrown is of type my exception and the number is odd, return odd. If it is even, enter in this block and return even. Again, this is pretty useful, especially, in my opinion, of course, when handling HTTP request exceptions, because now you can just catch the general exception here, of course, casted to the correct data type, and apply a check to the status code and handle the cases in different branches. So this is my favorite pattern when handling HTTP errors. Now, I should do a rant, but I will stop here because we are talking about interfaces with concrete implementations. The first time I saw this new functionality, I was okay. I'd better not say it publicly. By the way, it doesn't make sense, in my opinion, to have a default implementation for an interfaces because, again, in my opinion, an interface should just define the possible operations that are subclass, that are the implementer class should expose. By the way, they added it. I have to showcase it. So let's go with this way. We have the immediate downloader class, of course, with one method, the default one, download, that accepts a type and an ID, and download video, whose default implementation is just a call to the previous method, so download, by passing the specified value. So, of course, if a class wants to implement both methods, feel free to do that. So nothing differs. But if you want just to implement the download method and you accept the default implementation, and so it's just a kind of proxy defined in the interface, you have to accept that when the client call download video, it passes this specific value to the download method. Clearly, it works, and we can create a new class that implements immediate downloader by just implementing the basic download method. When I call it by adding a fact, immediate downloader, so the interface whose concrete implementation is media downloader. When I call download video, I'm actually calling the default implementation and getting I am a video, and that's it. Honestly, I get this functionality. Some people told me that it's pretty useful. I want to hear your opinion later. Let me know. But first, let's talk about validation. Okay, maybe it's not that fun topic, data validation, but okay. Yeah, we used to do validation manually. So, for example, if a method is, if a variable is null, don't know, throw new argument exception. Okay. Again, nothing fancy. But now we can add a kind of guard clause by specifying, by calling directly argument null exception dot throw if null and passing the input value. We can both specify manually the name of the value that is null in this case, or let .NET decide and guess the name by reflection, basically. This new way is useful again for data validation, maybe in your constructors when you need a dependency, dependency injection that you don't know if it will be created. Argument.null exception will throw automatically for you without all the without doing it manually. Again, it's probably the 1000th time I've seen it, nothing fancy. Finally, let's move to some new methods that have been released in LinkU. But first, just a second. I know it could be pretty boring, but it will be pretty useful for your day-to-day job. In LinkU, they released some new methods. So, for example, let's talk about ordering data. Clearly, you can use sort, the sort method, but if you want to use order, you can use order by. So, by specifying the property that will be used as a comparison type. So clearly, I have the user with an ID and a name. I can tell, or I can say order by ID, and it will sort the list by ID. Clearly, of course. But we can also let LinkU use the default comparison. So when we create a class that implements iComparable, or it could be just a list of integers or strings or whatever, by the way, that can be where you can compare two items. Instead of using order by, you can just call order. It will use the default comparison or the one you defined and sort all the items as you wish. Nothing fancy, and it would be pretty similar as min by and max by. So again, instead of defining max by the name of the property, min by the name of the property. No, sorry, silly thing. It was the opposite. Yeah, now we have max by and min by, because we don't have to order the whole collection first and then take the first, the max and the minimum, but we can just call min by and max by specifying the property. Sorry, I was wrong before. So it's a pretty useful item instead of creating the collection and taking just the first. You can call max by and use it. But the example before was similar to distinct by. So again, we can create call distinct by and specify the name of the property that will be used to apply the distinction of items. So all those items are distinct by ID, and if of course we'll use the list of items, check the IDs of all the items and apply a distinct. And that's pretty it. We are almost at the end of this section, so okay. With just another utility method, the chunk. So when you have a collection of items and you want to create, I don't know, a kind of pagination, instead of doing it manually, you can call the chunk method. in this case, I specify chunk with the parameter of 2, and it will create a list of chunks. Each of them contains exactly 2 items, of course, exactly if you can fill the chunk itself. So by calling it on a collection with 20 elements, chunk by 2, it will create a list of arrays. So we have 10 arrays. Each of them contains the 2 elements, so split by chunks. Clearly, if you cannot fill the whole chunk, it will leave the last one empty. So in this case, we have just 5 elements. I call chunk with 2. It will create 0, 1, 2, 3, 4 left alone in the last part. Finally, the last method we will see today. It's a try get non-enumerated count. And it's applied to collections, basically. But why? We already have a count and length and whatever. Yeah, that's right. We have them, but using those methods, it means that .NET will have to check all the items within that collection to understand the exact count, basically. Of course, with performance issues, because if you have 2,000 elements, you have to check to access every single item in the collection just to get the number. It doesn't make sense, clearly. So they come up with try get non-enumerated count, which of course will not enumerate all the collection, but return just the length of the collection without huge impact on performance. Pay attention that this means this is a guess on the count. In fact, it's try get non-enumerated count, because sometimes you just can't. You can do it, of course, when the collection is already created, so it may be a list, an array, or whatever. But sometimes, especially when using the yield keyword, you just don't have an idea, because the yield keyword creates the collection while you are accessing it. So you cannot get the final count if you still don't have the collection created. So this should be the preferred way to access the length of a collection. Clearly, if you have control on what's going on, if you know that internally it's a list, use it. If you don't know and suppose that it may be created dynamically with the yield keyword, just use the count on the length method and enumerate all the whole collection. So it's a matter of knowing what's going on in your code base. Okay, so now the code examples are done. Let's see if I can get back to the presentation without starting from the beginning. Okay, right. We are already at the end of this session. We, of course, have .NET 8 coming late this year. I didn't add examples about .NET because it's a preview, and we don't know what will actually be released until the very day of the release. It happened that they announced some functionalities, but then they did not release it in the final version. So I prefer just to focus on .NET 5, 6, and 7. Of course, we have some sneak peek about what will be released. For example, an improvement for the JSON serialization and the serialization, talking about performance, of course. 2 methods that can be pretty useful that I generally create them manually every time I need them. So get items and shuffle. So of the random class. So for example, random.getItems you pass in as a parameter a list or an array of items and the length of the final collection that you expect. And it picks random items from that collection and creates a new list for you. Similarly, random.shuffle shuffles the collection in a random way. So I generally do it as, I don't know, values dot select underscore x order by random dot next. It doesn't make sense. They added this new version for us, random dot shuffle. For those who use a reflection in an important way and care about performance, they added some new improvements about reflection that will probably boost your performance. And let's see, I don't know if somebody actually still uses reflection these days, but it still could make sense. Finally, we are at the beginning. I want to thank you all for your attention. I know it was a rush. Some parts were pretty boring, I have to admit, but they were important to know to level up your code base and understand what's going on in the .NET environment and for the future. Again, if you want to contact me, I'm on LinkedIn and on Twitter at Bellone Davide, and clearly my main blog, which is codeforit.dev. So if you have any questions, I'm here.